Assalamualaikum warahmatullahi taala wabarakatuh. So kita teruskan kelas kita hari ini. Bismillahirrahmanirrahim. The wave particle duality. Okay, so we need to understand what is mean by the wave particle duality. So we start the class now. So a moving particle sometimes act as a wave and sometimes act as a particle. Okay, all the moving particle can be described. So all the moving particles can be described either as a wave or either as a particle. So the moving particle. So that means the particle have the velocity v. So particle can exist in the form of wave, and the wave is known as the de Broglie wave. So assume this one is the particle. So the particle is moving the velocity v, and then it can form in a wave. So this type of wave we call as a de Broglie wave. Okay, so we continue. Okay, so according to the Max Planck, so energy of electromagnetic radiation, so E is equal to the HF, or E is equal to the hc over lambda. So we can get by using this relationship. So according to the Albert Einstein, so energy contained in a mass E is equal to the mc squared. Okay, so and then we have the E here, same here. Then we hc over lambda equals to the mc squared, and then we manipulate the equation, then we can get this equation. So this lambda wavelength is the Broglie wavelength is equal to the h over the mc. H is the Planck constant, m is the mass of the object, c is the speed of light, if in this case the object is moving in the speed of light. Okay, so we continue. According to Albert Einstein, energy and momentum are related. So by this equation, E power of 2 equals to P power of 2 C power of 2 plus the m naught power of 2 C power of 4. Photon are massless. M is equal to 0. So here is equal to 0. Therefore, at last we have this equation. And then energy of photon E is equal to the HF, and energy is equal to the PC. So then we manipulate the equation. We have the HF is equal to the PC, and then we get the equation P is equal to HF over C, and then by using this relationship, so we manipulate the equation, and then at last we have this equation. So here is the momentum. P is the momentum, H is a Planck constant, lambda is the de Broglie wavelength. So we have this equation. Now we know how the wavelength, the Broglie wavelength, is related to the momentum. Okay, so we continue. So we go for the quantum effects. So quantum effect is the experiment that proved the hypothesis wave particle duality by the de Broglie. So the quantum effect. So incident light with the short wavelength hit the metal. So from the observation, so the scattered light has a slightly longer wavelength than that of the incident light. Okay, so here is the incident light. So the incident light dia hit the electrons in a metal, and then we have a scattered wavelength, and then we also have the electron here. So scattered wavelength from the experiment is the lambda prime is bigger than the lambda. Lambda is from the incident light from here. Okay, so this one is from the experiment. So what we can conclude from the experiment, so the incident light lambda collide with the electrons in the metals, causing the scattered wavelength here, wavelength to get energy and momentum. So and then what we can see here is from equation P is equal to the H over lambda, and then lambda is equal to the H over P. So from the experiment, the momentum of the scattered wavelength is very small. So according to this equation, so the wavelength is longer. So the scattered wavelength get energy and momentum from the incident light, because incident light behave like a particle. So that's the proof, the Compton effect prove the wave particle duality, because question is where the scattering wavelength get the momentum, so get the energy, so actually get the momentum, so from the incident light. So that means the incident light can behave as a particle. For that, thank you very much.